Yeah, it's 3 o'clock my time and we can start. Hi, everyone again, and good morning, good afternoon, wherever you are. And thank you very much for attending today. This is my first time speaking at Collabsphere, and I'm proud to be part of this amazing list of speakers here. I hope next year I can speak again, but face-to-face this time. As we have little time, lot of content, let's start. This is Serdar speaking from my home office in London, and I am originally from Turkey, if you know me before that, and I moved to the UK 2 years ago. I have been working on Nodes and Domino for over 20 years now. I'm a Nodes Domino Java XAgents developer and transforming into a bloody admin in Full Moon, and also errand boy for my own company. And I'm an enthusiastic believer in open source software, so that's why I am also a proud part of OpenNTF board as a member director. Of course, before we start, I would like to thank all sponsors of Collabsphere. These companies play a crucial role for our community by providing financial support or support in other with other vehicles to these community events. So please spend some more time to see their sessions in between. And the actual session, today I'm going to talk about designing RESTful APIs for Domino applications. If you know this, probably you have seen this before, because I have been speaking about this same topic a couple of times in the past. So this time I will take the RESTful architecture part a little bit shorter, because HCL, thanks to HCL, they are adding new methodologies, new content to the second part. The first part, we are going to have a little chat about RESTful architecture. I will try to explain the basics of RESTful architecture to base or support the basics of the second part, and that part is the real deal. And we are going to have a talk about Domino methods, different Domino methods to provide RESTful services. So let's get started with a simple question: why should we care? I mean, today, we can't resist these three things anymore: user experience, business processes, and of course, integration. And first of all, many legacy Domino applications needs a serious facelifting, and we probably want to keep our data and processes back in the NSF for many reasons. Maybe we don't like other languages, or maybe we don't want to learn a new database. We don't want to migrate all the data. Whatever the reason is, an API could help us to integrate existing backend to much better experiences in the front end. The second is, IT world is becoming a huge jungle, and increasingly we are getting more demand to integrate with other animals and plants in this jungle. And using text files to integrate is no more valid or no more practical, especially with distance applications for obvious reasons. And RESTful became a common language between different developers from different technologies or different backends. Last but not the least, business processes are evolving fast, and they are getting bigger and bigger, as specialized as they are. And Domino applications are part of these business processes, and we have to talk to other business processes in the software world. We have to talk to Salesforce, we have to talk to CRM or ERP processes, etc. So there are many solutions to coordinate these multiple APIs on the market, like Node.js or similar applications, and fancy applications relying to these APIs on the backends are becoming increasingly popular these days. I can add some more and more marketing buzz in these slides, but fortunately, I'm with all my geek friends, and Wikipedia will be enough for us. These orange words are very important to understand the basics of RESTful services. We are talking about a way to architect different services with nothing more than a set of constraints. And when played by books, RESTful architecture is supposed to provide scalability, security, and performance. To provide some examples, we are using much simpler data types, less number of protocols, simpler architectures, simpler URLs, and these intuitive design features. And I mean, these URLs, these verbs, gets and puts and deletes, with beautifully combined with resource names, parameters, IDs, etc. These URL conventions, I mean, they provide a more developer-friendly conversation in our applications. An architecture has this inherent feature. It's stateless, cacheable, layers, etc. There might be multiple points of entry, and it doesn't really matter who gets any request or who is cooking the meal at the backend. And what client sees is only a service that responds to our HTTP requests. And in theory, this has a potential to scale up very effectively, like these buzzwords. This is inherently scalable, robust, and resilient. It doesn't happen all the time, but it has a potential. Okay, back to reality again. REST seems like basically based on very simple mechanism of the web. As you see here, it's nothing new. It's the old school applications, but we are putting it into developers' life, and it had a huge impact. I mean, especially considering the evolution of the architectures in time. In today's world, our applications are much more divided into independent bricks talking to each other or orchestrating for a ultimate common purpose, which is called the application or the business process. And the practical implications are fascinating. All those little arrows here are representing RESTful channels between different software components. That leads us to the summary. RESTful architecture is everywhere. And as we said before, it's not just a hype, not just a product, not just a protocol. It's a solid architecture, well-defined rules, intuitive conventions, and it's vastly common adaptation in modern frameworks, etc. Now, as we get a generic overview on RESTful architectures, we can go into one level down to detail. I mean, we are talking about designing RESTful API, or maybe designing an API overall. And I should underline that here, API design world has two distinct camps now, code first and design first camps. I mean, code first, I guess, is coming from service-oriented architectures, but design first is something I myself feel closer to. To illustrate this approach, I will put here in a simple imaginary case study to talk about these design steps. And you might know, and I hope you know, this great collaboration site of OpenNTF. And thanks to a great team of curators, it's a created content aggregating all kinds of news and blog posts in the collaboration space. Not surprisingly, it's an open source application. It's running on Domino, again, not surprisingly, and it's an X-based application. And we have done significant work on that in the past. It's not the rocket science, but still, it's a proper application with different modules inside. Suppose we are going to design a new API, maybe for a React application in front of that, maybe, I don't know, we don't want to re-implement the backend of the application. There are waste data there. Designing an API would be great ideas to start. And when we start in such a task, we will probably start with the presentation layer and consider what we need to re-implement this front page, for instance. And from what I see stories, I see tags, I see authors, I see many different objects. These are all JSON objects, in fact, and simple JSON objects. We are calling them resources in the API world, in the RESTful world. Also, we need to see some recent stories here. We need to see stories by tag name, stories by author. So we need definitely a stories endpoint, and we need to be able to categorize that with author, with tag. We need to be able to sort it by date, etc. These are endpoint designs, and slowly we are building up these endpoints, documenting it, our favorite OpenAPI specs tool, which you have one, I'm sure. And we create some stubs for these basic services we need. We need to write all endpoints, and we need to put necessary schema for all data types, response types, maybe validation rules, etc., etc. And after some time, we will end up with such an API design. And we have not written any single line of code right now. We can later iterate new services if needed, but this is the big picture, and this is the guideline for us to implement our backend. This is guideline for the UI designer to implement front end in the future. I see a question now. Richard asks, is the collaboration today API and NSF database open source? NSF database is open source. This is, I'm talking about this open API. I put them into my GitHub account. It's linked in at the end of the session material. So you can, I just created this for experimentally for my sessions. In fact, that's not, the API is not something you can download now right now, but you can see on GitHub, of course. Anyway, OpenAPI specs provide this master project plan, and whatever language we use, we will use this, and we can articulate this with other developers, other front-end developers, for instance, to get feedback, integration developers, etc. So great thing is that they don't even need to know about anything related to collaboration today. I mean, tags are not called tags in collaboration today. They are categories, and they don't need to know that. There is no date field. There is an publication date. Somehow we put "an" to every field names, and they don't need to know that. We are wrapping this API, and we can provide whatever we want. So far, we built a contract. We designated a contract for our API, and this contract, we started from end product working backwards. This is the design first coming from. And this forced us to follow conventions as well. Now we can prototype the API and start coding. I don't think so, because the crucial part is the missing part. In general, this is procrastinated in real life. We didn't have designed some part of the API, the new API, like security. Security design is important because deciding how to implement is definitely connected with the security choices we made. I mean, if you are going to use token-based authentication, it doesn't mean, it's not a good idea to implement XAgents or web agents. In the same way, security nature of the product brings a life cycle. We have to plan it. Who will manage accounts? Who will manage tokens, etc. And there are also minor details we might consider. I mean, once API is out there, changing contract is generally out of question. If you are providing RESTful services and at the same time writing the front end app, it's no problem, go for it. But often that's not the case. I mean, documentation is more important than any development project, but we already started the OpenAPI specifications, so we are halfway through. We don't have a problem. Swagger and OpenAPIs these are great concepts to learn, especially for testing, mock-up APIs, etc. Let's take a deep breath now and ready to dive into Domino stuff, because it's time to pick the way we implement the REST service now. So which way is the best? There are different methods to implement a RESTful API for our applications in Domino. I think these categories will cover all polite and respectful scenarios, and let's review them one by one. I reserved the front seat row to the newest player on the market. ACL is creating something very important in their labs for a while. This is in fact bigger than it looks. The feature implications would be interesting to see. And it's called Domino Keep, ACL Domino Keep, which also known as, I think it's going to be known as Domino REST API in official wording. So it will hopefully make Domino Access Services obsolete. So it's currently on early access phase, and general availability is expected very soon in 12.01. And deep down, Keep provides an interface between Domino and RESTful consumers, but it's a bit more than that. Keep has several functions. It provides a form view agent access for Domino applications. It can tweak what we expose to the REST clients in multiple ways and add some extra security to the process. There is more. We can access design elements. We can access mail, address book, calendar, and also a huge thing is server administration functionalities. It also supports OData, open data access, which is very useful for data integration between tools and applications which are compliant to OData. And like Salesforce, like Excel, like SAP, you can directly put the data from Domino to these applications. Security is an important capability in Keep. It supports JSON Web Tokens within different scenarios. I won't go into detail because yesterday Graham and Chris did a whole session about JWT implementation. I recommend watching it. All security is opt-in in this Keep, because it's always access denied if not specifically given. One of the most powerful features is probably agent processing, and running agents from HTTP is nothing new. But what Keep does supports, Keep supports asynchronous agent call. You tell Keep to run an agent, it runs in the background in a separate thread, and when it's completed, it can call back any specific URL, and we can also pass parameters, pass document context, etc. And we can reuse our agents, maybe some of our business logic with a RESTful API. Make sure you check this specific feature, it's great. And another important feature is extensibility. But before that, I will explain some details about Keep architecture. When you install Keep, it loads Keep task in the Domino server, which is the bridge between Domino world and outside world. All HTTP requests are coming into this task and the listener, and they are transferred to the event bus, something named event bus. And Keep is based on a technology named Eclipse Vertex, which is a reactive toolkit for Java. It's not a big deal for now, but it's built of verticals. And if you know how to build a vertical, which is like an actor doing specific jobs in the event-driven environment, the nice thing about this architecture is if you know something about vertical, if you can provide verticals to the system, you can extend these capabilities of Keep. I mean, you can add new capabilities, add new processors, add new services, etc., etc. Also, I'd like to share an exciting detail here. It uses something like Domino JNX, and which is the next generation Java API for Domino, supporting some modern Java feature. And thanks to Carlstan, I think I saw Carlstan here, and he wrote the Domino JNA open source software. Domino JNX is the next generation of Domino JNA, I guess. So it will be open source, I guess. I don't know the details yet, but this is very exciting for me. We already had OpenNTF Domino API as a great Java API replacement, but it was based on classical Domino Java API, and it was bringing some of these junks from the old API. So this is a new one and pretty exciting. Anyway, bottom line, this is an exciting project to watch. If you attended one of my sessions before, you would notice that I have removed Domino Access Services. I hope it's going to die for a good reason, because I think Domino Keep will be a great replacement for Domino Access Services with much more capabilities. And it defines the right way to do this RESTful API. Just keep in mind, it's all about data. You can borrow some of the business logic, like by agents, like a little bit formula magic, but it's not something you can write a brand new service for your application. And on the other hand, if you are looking for a development environment accessing Domino in a semi-native way, let's say, UpDevPack would be your friend, and you can use, for instance, Node.js to develop RESTful services. This feature came into life with UpDevPack in Domino 10 and evolved into a certain maturity in Domino V12. Node.js support is a very important improvement, I think, in Domino code stream, as this new platform is quite popular on the market, and there are numerous possibilities to architect our applications in the Node stack, and there are many tools we can use. In the same way, UpDevPack contains a Java bindings to access Domino on remote, and it turned out that basically it provides potentials binding other languages as well. So you can bind .NET, you can bind C#, you can bind other languages, and they can access UpDevPack features, and they can provide a semi-native interface for Domino applications. Let's concentrate into Node.js now and see how it works. Of course, we have Domino server, we have NSF databases, and we also have a Node.js stack. And Domino UpDevPack brings a new server task, which is called Proton. You install that into Domino server. And UpDevPack also brings a JavaScript module called DominoDB.js, which communicates with the Proton task using a special protocol named gRPC. This is our whole setup. We can start coding our RESTful services in JavaScript, I don't know, using Express or any similar RESTful service library. And we can utilize DominoDB.js module to connect to NSF data beautifully. Other applications will just connect to our JavaScript module, and they don't have to know anything about Domino server on the backend. And here's a little bit of Node.js code. As an example, some endpoints for Collaboration Today application, they are all in my GitHub account. And as you see, it's plain simple JavaScript code, accessing Domino database using DQL, etc. This code is, the link is at the end of my slide deck. DQL, let's talk about DQL a little bit. I mean, HCL or IBM developed Node.js modules in the time, and instead of providing low-level access, they created an optimized query language or query technique. This is a very powerful method to query Domino data with a very high performance. And I would recommend John Curtis's yesterday's session to have an understanding why DQL is important and why it has so many potentials. Another important topic, I will skip silently and in a speedy way, but it's a huge topic. It's IAM. Identity and access management. It's coming with UpDev pack. It's completely for authentication purposes. It's using token. It supports OAuth and different technologies. I definitely recommend Canadian user group videos about how to configure this IAM. So bottom line, if you were to choose a solution now, that would be a tough choice for you. Because from capability point of view, I mean, UpDev pack seems a little bit more capable right now, but actually it's about maturity. But at the end of the day, you can use UpDev pack to develop brilliant Node.js microservices, or you can choose any language you would like and expose some Domino data in a nice and clean way using Keep. It also depends on the need. UpDev pack using gRPC protocol, and it has its own advantages, like especially on the performance basis. But with Keep, you are stuck with the HTTP, but you will eliminate the need of middleware completely and go straight with a browser application or a mobile application directly. And personally, I would rather have both solutions in the portfolio because UpDev pack creates more language binding, can create more language binding in the future and provide more options to the especially outsider developer community. And it's also good to bring new blood into the market. So we have a couple of old methods, let's say. We have existing apps, especially when we have an existing apps, especially in X pages. We can develop simple and quick solutions with our old friend REST components. So this is what I generally prefer for quick add-ons. When I need a small ad hoc thing, small integration scenario, maybe a UX enhancement like type ahead or data table. These components are nicely provided by HCI or formerly IBM as a part of the X pages, and they provide programmable wrappers for old Domino access services. They allow us to customize almost anything, almost everything in the system, including response and deciding which fields to be exposed in great detail. And also we can write our own services in server-side JavaScript or in Java. They can also implement small kind of event model, so we can put some business logic, especially on create events, which was the missing point in Domino access services. This is okay for small scale integration scenarios, maybe these UX enhancements, but far from perfect for larger scale implementations. First of all, your code will be spread around the design, and inherently it has a major potential to end up with a spaghetti code. Of course, we can still hard code everything by ourselves. This is old school. We can use agents, XAgents, etc. Sometimes you might even want to prototype simple ideas with a quick and dirty XAgent within your database. It's very convenient in such cases. Or you have hundreds of thousands of lines of codes of Lotus script, all tested and proven to work, and you want to use them, easily wrap them into an agent and provide RESTful services. But obviously, this is based on hard coding, and you have to deal with every little detail. You have to, and code organization is still a problem because it doesn't impose a certain architecture. It just fits where whatever you write, and you write ugly code, it turns into a spaghetti code. But still, it's an ad hoc solution. I don't recommend it for mid-scale or large-scale implementations. And speaking about large-scale implementations, let's take a more complicated approach. Java has defined JAX-RS as a pattern for creating RESTful services in Java way. For instance, Apache Wing is one implementation of this. I gave this example of Wing because it's already shipped with the Domino, because Domino Access Services was written on top of Wing. It was also used by version premises and I think Traveler stuff. And this is a complete Java development and potentially involves some OSGI plugin work. Very useful, very effective for large scope implementation. I have used a couple of times. And also, there are a couple of different ways to bring Java into your RESTful services. But before your options, let's try to understand JAX-RS. There are multiple preloaded in JAX-RS. Actually, you unknowingly design a part of a huge Java servlet. So what your code is automatically placed into a Java servlet, into a partial as a Java servlet. And there are multiple components here helping layering, layering and scalability. And like runtime servlets, request response wrappers, context helpers. If you understand anything on slide, I don't know, you don't have to listen, but let me summarize this in a more understandable way. In a closer look, what you have implemented is just that. Bunch of classes, bunch of methods. The core concepts of RESTful services are beautifully adapted into simple Java classes with these little guys named annotations. If you are not familiar with these annotations, they are simply syntactic sugar over Java classes, methods, variables to mark them for specific purposes like this. Path annotations here, path annotation here, just to declare the path of the resource at the beginning. So slash contacts, this resource is going to be used for this specific type of path. Also, there are other annotations for methods like get request, like sometimes we can use get and path request together. And we can also use path patterns to grab some variables from the given URL pattern. Annotations can inject this request data into our methods, and it will take care of type safety, conversion, and also error handling for those injection. I mean, if you are putting string into an integer, it will give back a nice exception to the consumer. We have response builders. We can easily construct a response. We can provide a response code at the same time, and we can create exceptions automatically converted to error responses. Moreover, we can have much more complicated responses like downloading a file using a stream, etc. Let's finish with a post example. The same methods can be implemented to easily for multiple types of input data at the same time. And JAX-RS processor will pick the right method depending on the incoming data type. And we can also inject those data automatically into methods as well. So, JAX-RS can be used inside or outside. I mean, we can develop a OSGI plugin. We can develop a JAX-RS Java classes within our NSF. Let's take a look at this briefly. We can package all extensions, all these, I mean, extensions on the right, resource classes, tools and utilities, controllers, accessories, etc. Everything packed in a OSGI plugin. You can use Eclipse to do that. This is the difficult way, but it pays off for large and specialized implementations. Alternative is to use Jesse Gallagher's Jakarta EE plugin. It's an open source plugin available at OpenNTF that allows us to use JAX-RS annotations right inside our Java classes without dealing with any plugin. This is very desirable for many developers because we want the simplicity and the convenience of these clean-cut methods to implement RESTful services. But at the same time, we don't want to make it big deal with OSGI plugins, deployments, update sites, etc. Let's give some credit here to Martin Pradny. He has done significant work as an initial, and also Jesse Gallagher for importing this into an open source OpenNTF project. And of course, there are minor issues caused by XSP engine, which unloads and unloads classes on the fly, and interferes with whatever going on at the servlet level. But this is still promising, especially for many small-scale implementations. The last idea is more of an early stage now, but this is again from Jesse and is inspired from Sven about this. Basically, you might run a full-scale Java enterprise application or server, such as OpenLiberty. You deploy a part of Domino runtime into Liberty runtime, and you can run on Liberty and access to Domino Java API directly. So years ago, IBM was promoting a similar method with DIAOP. I think it's dead finally, but which wasn't the best, but proper and for very simple cases. But at this level, we have further advantage for sure. So looking at the dark side, I mean, this approach is not easy for inexperienced developers, especially the plugin part. I mean, you have to learn plugin development, and that's why it might be an overkill for really simple, small projects and needs. Also, the tool selection is critical. Apache Wing is part of product, but it's an old school API. It's not even maintained anymore at the Apache. Other implementations are great, but there might be issues to integrate them into ACL Domino. And using JAX-RS inside NSF, on the other hand, is an OpenNTF project, and you need to make sure you know what you are doing if you are using that kind of add-on. There are a couple of sessions. I mean, I had a session 5 years ago about solely on Apache Wing, and Jesse had his own GitHub project. You can look at it. And so far, we have talked about different methods, and all of these ideas are great, but they may not be perfect as we see so far. So there are ones easy to implement, others they are difficult but convenient, and so on. And our last option may be to use best of different worlds at the same time. In this scenario, we can use a Domino keep service for one thing and reuse a couple of XAgents already designed, maybe implement a very complicated process in the JAX-RS, and bring everything down, wrap them with our favorite language, for instance, the favorite framework, for instance, Node.js or Spring, etc. We can add some non-Domino services on the way and put some magic to the process. And this is the hybrid way to go. In a hybrid approach, we can combine all these services into one middleware. And this will provide a consistency for security, for use of URL, for optimization with caching and similar techniques, etc. I have added some tooling recommendation at this stage, but we probably don't have time for it. So I leave it here for Q&A, and make sure you can look into those tools, and there are testing tools. And finally, once again, we thank to all sponsors of Collabsphere, and of course, all Collabsphere team together, such an amazing lineup for this online event. And I guess we can have a couple of questions because we have 5 minutes. By the way, in the end of my slides, there are a list of resources for my session. Make sure you look at them. Otherwise, thank you everyone for attending my session, and have a good one.